Okay, so your question is
One vector is 2 1
okay, 2 1,
1
right?
and another vector is 0 0
So another vector is
0
0, and the this is also
0.
0.
Yes, sir.
One second. Right. So now your question is whether nulls. Okay, what's your question?
Does null space exist for us?
Okay, whether null space exists. Okay, so let's go one by one.
Okay, sir.
Okay, um, the first thing is whether these are linearly independent or dependent.
Linearly independent. We can't make it 0.
No. See, for example, 0 into first column,
0
okay,
into
plus anything into
yes,
second column is still 0, right?
but it's trivial.
No, it's not a trivial. When both alpha 1 and alpha 2 are 0, then it's a
It's a
trivial,
trivial.
okay?
Yes.
But we can have a non
2
zero
is
alpha 2, right?
any alpha 2.
So, which means the first thing is it,
Alpha 1 is
it cannot reach, so it's linearly dependent, okay?
dependent.
And if it's linearly dependent, the null space exists. So,
Exists.
one thing is if it's linearly dependent, I cannot reach
Certain
all
point,
the
points in this.
yeah, certain points, or I can reach only certain
Certain
points.
points.
Okay, so for example, if you notice here for this case, you can reach once again along that line,
Yes, sir.
right? You cannot reach anywhere.
Yes, sir.
Okay, so it's a linearly
Dependent.
dependent. Okay, and now what is the null space? Okay, so the null space is, so once again if you go here, okay, so anywhere
0
in the,
comma y.
yeah, 0 comma y, that's a
Null
null
space.
space, because 0 into first column plus something into second column is 0.
0.
Okay, so therefore that's the null space. This entire line
Is a
in the axis, this entire axis is the
null
null
space.
space. Okay, and say for example, if that's your output, then the solution is, all you need to do is, if you just drag here, the p2
Set
will not change.
change
Okay,
along that y axis.
yeah, okay, okay. And one more thing we can discuss, in this linearly independent, this particular case, okay, uh, what's the eigenvalues and eigenvector? Okay, so there will be two eigen
Values.
values and eigenvectors, right? So for this matrix, what are the eigenvalues and eigenvectors? Could you try? Okay, so I think maybe if you drag it to right, so now that's the eigenvector, and what is the
Comma.
corresponding eigenvalue?
Sir,
Eigenvalue for that eigenvector. So A into P1 is equal to lambda
la-
into
eh,
P1
P1.
itself. Then
Yes.
what is that lambda? The P2 is nothing
P2.
but lambda into
Lambda.
P1.
Yes.
What is that lambda? If you multiply P1 into 2, you
2.
will reach P2. So
Yes.
the lambda is 2.
2. Yes.
Okay, fine. What is the other eigenvalue? Eigenvalue and eigenvector?
only one.
Okay. Now what I want you, so you're telling that there is only one
Eigenvalue and
eigenvalue and eigenvector. Okay. So for this matrix as well as the other matrix like 2 1 4 2, okay,
okay, sir.
for those two matrices I want you to calculate eigenvalue and the eigenvector, okay, and you check whether only one eigenvalue exists or is there any two eigenvalues and
Okay.
eigenvectors, okay.
Yes,
Yeah.
sir.